Hey guys, so today we're going to do section 2.2, part 2. So as a warm-up, rewrite this sentence as a conditional statement in the form if, then. Alright, so looking at this statement here. Tourists at the Alamo are in Texas. So we want if something, then something else. So the hypothesis. So tourists at the Alamo are in Texas. So if they're at the Alamo, then they're in Texas. So if a tourist is at the Alamo, then he or she is in Texas. All right, I ran out of room, so I had to write it like that. So you can't say if you're in Texas, you're at the Alamo. So if you are a tourist at the Alamo, then he or she is in Texas. All right, we finished class last week with this figure here. And just looking at the figure, what are we allowed to assume that is true? So just looking at the figure without even looking at A, B, or C yet, we have two lines intersecting at point E, and there is a right angle box at angle BEA. So let's look here. Line AC is perpendicular to line BD. Well, since we have that right angle box there, that is said to be true. Angle AEB and angle CEB. So AEB is this angle up here. AEB is this one up here. Yes, we know that it's right, but it's still that angle. And CEB right here, this other angle. I'm going to just do that just because I want to focus on two different angles right there. I know that they are equal. They are a linear pair. A linear pair means they create a line. And since AC is the line and AEB and BEC, or CEB, depending on how they wrote it CEB, create this line right here, we are allowed to assume that they are a linear pair. So that is also true. And the last one, ray EA. Ray EA starts here and goes that way, is opposite to ray EB. That one is false. Opposite rays, we would need to be ray EC like this here, because they have the same endpoint and they're along the same line, but they gave us EA and EB, so that one is false. Alright, so hit pause and take a few minutes and try these 3 guided practice problems from your textbook. Draw the figure down so that you have it over here. And we will be sure to go through these questions in class next time. Alright, biconditional statements. When a statement and its converse, remember converse, think backward shoes, so you just switch your hypothesis and your conclusion. If both the original conditional statement and its converse are both true, then we can form it into a biconditional statement that uses if and only if. Any type of definition of something can be written as a biconditional statement. So, writing the definition of perpendicular lines is a biconditional. So, the definition. If two lines intersect to form a right angle, then they are perpendicular. The converse of that, it would be if they are perpendicular, if two lines are perpendicular, then they form a right angle, which I have right here. Notice just the hypothesis and the conclusion switch spots for a converse. instead of having to write both of those statements in math and geometry, what they do is they write either one, doesn't matter which one comes first, just make sure you're identifying what you're talking about. So 2 lines, that comes in the first one. Notice here, if 2 lines, they didn't have 2 lines over here when they moved it that way. That's what I mean by in the beginning. Just state what you're talking about in your hypothesis. So 2 lines are perpendicular if and only if they form a right angle. So that means, depending on what you have, you are allowed to go from left to right or right to left, meaning hypothesis to conclusion or conclusion to hypothesis. So let's try one. Rewrite the definition of a right angle as a biconditional statement. All right, so definition of a right angle. If the measure of an angle is 90 degrees, then it is a right angle. So rewriting that as a biconditional. We need 2 ways, biconditional. So, doesn't matter which one you start with, so I'm going to do right angle first. So, an angle is a right angle if and only if it measures 90 degrees. So instead of having to write if it's a right angle, then it measures 90, and if it measures 90, then it's a right angle, you can just have the if and only if. Put off to the side here. Mathematicians get to be lazy sometimes. Instead of writing if and only if, you may see, it looks like a typo, they'll use the word if with 2 F's. They are talking about if and only if. So write that down. That means if and only if. That means biconditional statement. All right, hit pause and try number 12. Rewriting these 2 conditional statements. If Mary is in theater class, she will be in the fall play. And if Mary is in the fall play, she must be taking a theater class as a biconditional statement. All right, that is all I have for you today. Please write down your answers to the guided practice that I will check next class, and make sure to let me know if you have any questions. Thanks, guys. Have a great day.